Okay, we are alive now. Good afternoon, good evening for everyone that are with us in this presentation. Today we have Prasath from India. Welcome to our event. The last year you participated to, and it's a pleasure uh, receive you in our event. Praja, thank you very much. Praja, it's from Chennai, India. He includes the sub Chennai community too. He's a SAP consultant and solution architect in SAP supply chain management, and today he is giving us some information and some knowledge about the planning production. Let's go, Praza. Thank you very much.
Thank you so much, Nuri, for the deeper introduction of it. So, yes, as like I'm glad to be participate this SAP for class as like last year. I'm really happy to be part of this current year as well. So, yeah, maybe today we will deeply talk about how material requirement planning has been optimized in SAP S4HANA, on what is the potential benefits to the business and what is the impact which has been created to the business. And also we will talk about what is the next generation of MRP is going to play a role in the business impacts. So if I'm talking as the Marvel introduced about myself, yes, I be a kind of SAP logistics expert who takes care of all the logistics module. I've done almost more than 5+ SAP S4 on implementation. I've done a rollout in 5+ and also did a migrations of ECs to S4 and 6+ projects. So I'm been part of the almost all the kind of industries like automotive, agricultural equipments, beverages, foods and consumer products, and even into textile industries as well. Yeah, as I given the introduction before that, we will talk up deeply discuss about what is the MRP live, and also we will talk about the what is the predictive material resource planning. Shortly we will call it as PMRP, and also we will talk about the what is the demand driver material requirement plannings, and also we will just will have the touch upon the what is the next generation of MRP is going to be in ACPs that we'll talk about. This is the four topics which we talked about today. And when we talk about an MRP live, it is something different from a classical MRP. Maybe when it comes to an MRP, it's not the new kind of an elements or a kind of a component. MRP is material requirement planning, which is be there from the maybe even older days, almost more than a decade back it was there. But whatever the logic which is behind or built in then that ECC and S4 on it is quietly different. When it comes to any classical MRP, the lot of logics and whatever the algorithm which has been built on classical MRP that is quietly changed in our MRP live. So in MRP live, you can able to do the planning of the multiple plans in the single transaction, that is an MD01 and also you can able to get this some kind of an optimized sourcings, and also there is some redundant data like some multiple material master or kind of a master data for MRP that has been kind of simplified in MRP line in that's in test for HANA. When it comes to an predictive material resource planning, it is when it comes to an talk about the predictive, yes, the name implies to that system can able to do then the predictions, it can able to generate then optimized result, and it will be potential benefit to the production planner who does the production activities and the material planning activities. Also, it is giving the major business impacts when it comes to supply chain optimization. When we talk about a demand-driven material requirement planning, so it is as like an the demand, whatever the demand which is comes from the forecast and whatever the that will going to drive the material requirement planning. It's help us to business to keep the less inventory and also making sure that the right material has been placed on a right time. When it comes to our next generation of MRP, yes, we will talk about the what how the when it comes to next generation is now, as you know very well, like now that the generative AI and an artificial intelligence and those things are placing a major role in its comes to industries, and also those elements will also be touched upon the material requirement planning in SAP as well. So master data for MRP, it's everyone knows. Yes, we load in bill of material, which is it's a kind. It is talks about the list of material or a list of a component which is used to produce a semi-finished or a finished product. And routing and recipe, it is talks about the what is the list of operation we are going to carry it out, and what are the list when it comes to process industries, and what are the phases is going to be required to make sure that the finished product or semi-finished product is being produced. And production version, it is talks about the what is the combination of routing or bill of material which is required to produce the any materials or FG products. Where you can when you talk about a production version in SAP S4 HANA, maybe in SAP S4 HANA it is a mandatory, but in ECC it was not. In SAP, what they made it is to explosion of any component in S4 HANA, they made it as a mandatory. It will ensure that the business can able to have the multiple production version depends on the lot size, depends on the capacity, whatever handled is in the same scenario, you can have the multiple production version as well. And also you can able to restrict the work center. Suppose example like having work center which can able to operate with some minimal amount of time. By the time you can able to have the lot size based production version to making sure that if the incoming demand or a forecast demand to received from the customer is something we were not able to produce, so you can just fix the lot size as well, that you can able to have the multiple production version for a product. And also the planned independent requirement, it's a kind of the demand, what are the demand which you received from the customer, the forecast data which you received from the customer, that will be feeding into the SAP for the planning activities. And what is we will talk about the something deeply on the what is the PMRP? PMRP, as I told you at the beginning, that's a predictive material resource planning. What is basically predictive resource planning? If you look at this picture, it will give the clarity about I have to build some kind of a room where the people will talk about in front of some microphone, and the speaker will be placed on in somewhere else in the room. If the person is talking in front of the mics, and also the speaker which has been connected to the microphone will be giving some kind of the sounds to the inside the audience or the conference rooms or a kind of any closed rooms. So whatever the sound which is coming out of the speakers, the audience was going to listen to music, so that they have to ensure that there is no kind of an echo which is coming to that, so that the music will not be much qualified. And also that what is that the sounds which they're hearing to the person, that's also going to be the kind of to be calculated. So what they've done is something like you can have the SPL is going to be in kind of a loudness which is equivalent to the distance between the person the person speaks on the mic and between the speakers, that's going to be an D1. And also X is kind of a constant or a variable which we will just call it as a X. And also we will call it about what is the distance which we just kept on the speaker, the person who was hearing the sounds, that we call it as a D2. So then again the sound is going to be in the SPL which is equivalent to the what is the distance between the speaker and the person is hearing, and also the X is going to be in the as like in constant or variables. If you talk about these both equations, like the soundness which is directly proportional to the D1 index, and another SPL is something is equally proportional to the X by DS. If you just have the two equations, you will get the actual the loudness which will be hearing to the person. So it will ensure that what is the range of frequency that it, so by adjusting this DS D1, if you wanted to calculate the particular D1 and D2, probably that you can making sure that the where the person should stand and where the mic to be kept. This should be calculated. It's having some kind of a mathematical logic is being placed. So as like same thing, no, you don't do a multiple calculation in this predictive material resource planning. So what the production planner can do, so production planner can able to enter the demand to the systems, and also you can able to run the predictive materials resource planning. System is does the predictions by considering the capacity, by considering the inventory, by considering the other kind of production activities and resource. By calculating all those things, product system is giving you some results. Suppose whatever the result which is given by the system, if it is not as per your need, you can no need to start, can still go and have the multiple iterations of activities until you get the optimized plan, as you done it for the how you calculated the distance between the speaker and the person who's hearing it. As like the same logic which has been already built in that predictive material resource plannings, where you can able to go with the multiple iterations of planning to ensure that you will get the optimized the results of the planning. So the production planner can able to do the similar, the kind of a simulated planning run to make sure that it will be a system will guide you to do the kind of an result to ensure that the correct action has been taken, and making sure that your the planning of material has been needed at the right times. And also you can able to mention the so if you talk about anything where you have some constraint, right, as like that anything which you could talk something, if you're able to take any internal combustion engine, if you just burn the fuel, you cannot able to get the 100% of out of the result kind of an efficiency. So there you have some kind of a constraint. So there are some scenarios, the what is that the fuel has been injected to the engines, it's going to be in completely and burst, it will get kind of an burn, it will be coming out of an energy, it is not always going to be an efficiency into 100 percentage. So as like same thing as in PMRP as well, you can able to determine the constraints, where what kind of a material has the supplier has the limitation, and is there what is the production line has the capacity. So those kind of an concern you can able to fit into the systems. So it will help you to do the prediction activities. And also after you've done the multiple simulation activities, and the system can people can able to take decisions out of this whatever the result which just comes out of it. And these are the basic the few application which is needed for the predictive material resource planning. One is process MRP simulation and schedule and PMRP creation simulations, and also the defined flexible constraints. What basically the schedule PMRP creation does it. So probably so the after you just enter the plan independent requirement to the systems, you can able to do the predictive material simulation that you can able to do that. So what the system will do, it will help you to do. You can able to determine the what level of planning you're going to do at a work center level, at you're going to plan at a top material level. That you can determine the level, what is the planning you're going to do at which level, and also you can define the what kind of template you're going to follow. That work center based, that you can have that the two templates. You can just choose the template, and you can able to choose the plan to at the plant multiple material MRP controller. Those things you can do the you can choose that, you can just creation the you can do the simulation creations. And after you just done with that the simulation creation, you can able to do you have to do the simulation processing. What is the simulation processing which does it? So probably after you just done with the process simulate schedule and MRP simulations, so processing of this MRP simulation, it will help you to do the define what is the if you after the completion of the process simulations, or a kind of a process create the simulation creations. So the system will help you to identify the what is the percentage of delivery can able to make, and is there any kind of an issues which you are having it. Those kind of an issue can be fixed at a process simulations that you can have. And define flexible constraint, as I told you, it will help this application will help you to define the constraints, to determine the sources constraint, to determine the STO or a kind of an in-house production constraint, and also you can able to do the constraints of the production version. Those constraints can be maintained through this define flexible constraint application for your applications. Yes, as I told you, like after you just done with the process the simulations, probably this capacity simulation application which help you to identify the what is the delivery performance after the just creation of the process MRPs, and also what is the capacity use. So these kind of this application will help you to identify the will also will help you to fix the capacity constraints. And also so then you will have the inspector panel on the Fury application at the right side, where you can able to identify the which the period has then red indicator. So probably that as this kind of a constraint, where you can just get into the number of the what is the red indicator which is there, you can able to fix it. If it is something related to the capacity constraint, or if it is something related to the constraint whatever defined in the application, you can able to identify those constraint, you can able to do the fixing of those values. And while you're fixing these constraints, probably you can able to extend your capacity, and also probably you can able to choose the multiple sourcing allocation as well. For example, so there's an the planning which is the same, and you can able to produce in 1,000 quantity, for example. But at the by the month you can have the 1,500. What you can do, probably you can able to choose the multiple production version for the months, to making sure that you can able to produce all those 1,000 whatever the quantity which you received from the supplier or a kind of a customer, you can able to make the adjustment in your production version to making sure that you will get the desired results. And also there are some scenarios you can able to do the pre-productions. For example, so there are some scenarios, first, second, and third week. Let's take an example of the 4 week. For every week you have the plan of an 100, but for the fourth week you have the plan of the 200. For example, yes, my capacity also only we have that 150 capacity. What the system it will help you to do? The fourth week you have the exceed quantity of the 50. For those 50 quantity, you can able to do the pre-productions to making sure that the 50 quantity can be adjusted to the previous weeks. Those kind of addition will help you to do these capacity simulations. And also the capacity simulation app will help you to do the kind of simulation like a multi-level material simulation as well. So you can able to explore the BOM for and finish the product at a top level. System will able to identify that at what level or which level of component has the constraints or kind of issues, so that you can able to fix it. If you look at this, whatever the screen which is given in that, so I have the issue of the kind of a third and the fourth level. So I can able to do the, it's kind of an outside the simulation, and also we have planning of the production on the particular month as the kind of a limitation of 4,500 each. So the right is whatever the data shows in the red color, it's kind of an inspector panel. Inspector panel. So when you're looking at those inspector panel, you can able to take a decision whether you wanted to adjust the production version, whether you want to adjust the capacity, whether you wanted to maybe do the pre-production activity, whether you wanted to change the source of supply. Those decisions can able to make in this process simulations. And also, if you're just done with if, suppose if you're satisfied with the whatever the result which you done need, so what you can do, the whatever the data which you done, the simulation that you can release to for the further activities. So probably have done with that. So after a completion of all the process adjustment or kind of a capacity simulation adjustment, I have able to get the 100% of delivery performance and also with the zero capacity issues. By the time what I can do, I can able to release the process simulation to the actual MRP requirement plan that I can do the release. When you do the release, you probably system will able to help you to do the at what level your demand should push through, and also what is the version the system should generate and the new plan independent requirement. So those kind of the value will be shown when you're just releasing the process MRP results. So once you just put the result, probably it will be creating the new plan independent requirement with the whatever the version which you wanted to do. So those kind of a result will be taken into the actual MRP planning. So for that, the demand will be ensured that you do not face any issues during the production activities or planning activities. You can ensure that the right material has been placed on the right time. So, at a nutshell, we will talk about this. The process MRP, the process flow will be as it is starts with it is starts with the kind of the planning, creation of planning requirement. Then it is on to the scheduling of the planning simulation, PMRP simulation, and once you're done with the scheduling of simulation creation, I'm going to do this process. I'll be going to do the processing of this. So during the processing, as I told you, what the system it does, it will have to do the capacity adjustment, the constraint adjustment, those kind of things, which is do that. So to making sure the process PM simulation, you will have this kind of data. Like as I told you, you will need the constraints that you can define the constraint of production line, or also you can do the constraint of materials and kind of a supplier. Those kind of a constraint, if you maintain, probably those data will help you to do the optimized to simulation data. After you're done with the simulation of the data, probably that data will be released for the actual MRP planning, that will be to create a new plan independent requirement. Then that data will be taken into consideration of the planning. Then those will be considered for the shop floor activities. This is the nature of the PMRP process flow. When we talk about the business benefits, to making sure that the production planner, the scheduler can making sure that there is no kind of an exceeding inventory will be placed on that, and also making sure that the required material has been placed on the right times. And also what its system will do, since it is given the optimized production plan, so the production planner can able to take a decision which is ensure that they can able to meet the customer demands. And also you can avoid the kind of an having the over capacity, and also can avoid having the kind of least capacity. So those two you can able to avoid that. And other topic we will talk about the demand-driven material requirement planning. So what is the basically demand requirement planning is? It is quite different from the our regular MRP. Basically, what the regular MRP it will do, regular MRP is kind of just push the data to the MRP to making sure that depends on the whatever the demand which you are having through the forecast or market system will do the planning activities depends on that. So but this demand driven material requirement planning is quietly different from the previous one. Basically, the demand requirement planning is something is the logics which we the given by the demand driven institute, that's an institute. So those whatever the logic which they built on it, that has been integrated with our the SAP demand SAP DDMRPs. So basically, DDMR will help you to do the planning efficiencies to make sure that whatever the customer demand which is received from the forecast or kind of a demand will making sure that you can able to do the planning of those material and raw material without having the issues like an over, you will have the over inventory. So those kind of issues can be completely avoided. So basically, what is the phases of the involved on this the DDMRPs? They have the kind of three phases. Like the first phase is called the position. Basically, what is position means? Basically, the position will talk about the you're going to finding out the what is the strategic items and kind of what is the component or material which is going to play a major role or which will be giving the significant effects to the markets. So those will be finding the position, and by the time you'll be having the product. What is the basically product is basically if you find if you're able to find out the what is the strategic item for your after the finding of the strategic item, you're going to fix the buffer level of the. So basically, the buffer level we talked about in any point of time, system will be ensure that the whatever the strategic item which is going to place a significant role to the market, which will ensure that will not go below that. So that at any point of time you will be able to get the strategic item in the right place, and also can do the pull mechanism. What it will be the pull mechanism. So after you've done the kind of positioning and after maintaining of the buffer level, after you're running the DDMRP, system will able to give the kind of cues by with a color indicator so that the planner can able to easily identify then what to be planned and when. So those optimized result can be will be getting through them after the DDMRPs. And after you get the result of the DDMR, probably you can able to easily collaborate with the supply chains along with the supply chain, the material supplied by the partners to making sure that the replacement has been done with the correct zone with it. And also you can able to meet the executable plan as per the customer demands. And when you talk about the nutshell of these the DDMRPs, it's a kind of the basic key process flow. It's an replacement planning and replacement execution. What is the replacement planning is? You will do the review of the component as I told you the what is the strategic item as the buffer components that you can able to do the buffering of those data, and also you can able to do the you can able to create the demand for those the finished products with an independent requirement, and also by covering the discrete also you can able to do this planning for the repetitive manufacturing industries as well. When it comes to replacement executions, you have to just review the replacement execution by referring the buffer components, and also you can able to do the take into the supply chain supply into the production executions, and also can able to reduce their and kind of an exit inventories, because since you're already find out the strategic component which is going to play a significant role, so the markets are kind of a finished product, so this will help you to avoid the over inventories. And also by this planning method or planning board, you can able to expedite the supply chain to making sure that you can able to meet the customer demands. Yes, it's again this is the process flow which is required for the DDMRPs. And when we talk about an AI and ML, that's a kind of what the next generation of MRP is going to be. And yeah, maybe this is the kind of latest or hottest topics in the global supply chain or kind of a global. And what is the artificial intelligence filter or the machine learning? What is the it's going to be do the impact on the supply chain? When it talks about the generative AI, now generative is going to play a major role to the CIO and CFOs, and those generative AIs will kind of help you to take the decision on it. What in when as like in other topics or kind of another component, this AI and ML is also going to play the supply chain major role as well. So what basically it will do, the AI ML, it will going to do the various data modeling and the data source, and also it will able to get the data from the historical data, and it will able to easily find the market trends. So by calculating those kind of a data modeling and the data algorithm, system is able to help you to find out the accuracy of the forecast. So by using the AI and ML, the algorithms, and also what it can do. So you want the once you're able to get them right planning data, and what if like you're just posting the data on the production execution, production activities. So what the AI ML do with the production activities is, so basically the AI and ML can able to easily identify the when the product, is there any product issues goes on the production line, or is there any kind of quality defects in the production lines. Those kind of data easily can able to get from the shop floor, and it push that, and it put the results to the system. So and again the system will do then prediction or kind of an artificial intelligence logics. The data modeling will do then recalculation of the supply chain to making sure that yes, there was an issue in the production line, so I got to do the detailed bill planning extras. And also it will help, the ANML will help you to kind of reduce the rejection which is happening in the shop floor. So that AML will be the kind of an A based visual inspection which has been placed on the shop floor activities at any point of time. If suppose that human can able to lead some kind of errors during the visual inspection, when it comes to an AI visual inspection, and maybe to more than 100% system will ensure that there is no kind of defect has been felt through the customers. So you can able to make the good quality of product has been supplied to the customers. And also what the vehicle will do, autonomous vehicle, probably what it will do, kind of so if it makes, let's make sure that when after the decade, probably the supply chain vehicles are kind of a transportation of vehicles will not have any human drivers. So the A or kind of an ML based will the logic has been placed on the vehicles during by the time. So probably that this vehicle will be able to find out the optimized routes, so that it can able to reach customer at the right time. And also when it's carrying in raw material to the shop floor or to the factory from the supplier, so it will able to easily give the signal back to the shop floor saying that I can able to reach on the time on the date. So probably the production planner can able to can easily can able to identify that when the material has been placed on the shop floor. So yes, this is the kind of this is the kind of next generation of the MRP is going to play a major role, and also ANML is going to do the impact on the supply chains. Yes, I'm done with that.
Nice, very nice. Thank you very much. Let me ask one thing, because the last slide was very interesting about AI and ML questions. Did you
Yes.
know if we have some model or some features in nowadays in S4 HANA to use AI and ML in supply chain?
Yes, yeah, it's already been maybe in SAP S4 on a cloud. They've been already implemented these logics on this to do the accuracy planning. It has been part of our IBP integrated business planning. Already this AI and ML based logic has been placed on integrated business planning. It will help you to find the accuracy of the demand and forecasts.
So we have some feature like that nowadays
Yes,
in
yes, we
MRP and some supply chain
supply
features and apps in Fiori.
exactly. Yes, it is there already. Not in Fury application, it is there in the
Yes,
integrated
yes.
business planning. Yes, it is there already. Yes.
Okay, I suppose that it's all. Thank you very much for your excellent presentation. It's always a pleasure to have you in our event. You had here in the past years too. We are grateful for that. Thank you, and we wait for you in the next year again, please.
Yeah, thank you.
Okay.
Thank you so much, Emmanuel. I'm really happy to be part of the. I'll continue to do the next upcoming year as well.
Bye
I'm glad
bye.
to be part
See
of this
you.
event.
Thank you very much. Bye bye.
Thank you so much. Bye bye.